So this session is related to planning experiment from 2017 session exam papers. In the question, a student is investigating how the material of a spring affects its behavior when it is stretched. So the following apparatus is available to the student. Student is having wires of different thickness, length, and a material. A set of 10-gram masses and a set of 100-gram masses, both with hangers or hook is there. A wooden rod approximately 1 centimeter diameter, and other standard lab equipment. Plan an experiment which enable you to test the extension of a spring made from different types of wires. So first thing, we have a wire and we want to convert the wire, like we have different types of wires are available, wires of different length or different thickness. So first thing, we want to investigate how the addition of a load or adding a load to a wire can affect its extension. So, but we want to make a spring. So how we can convert this wire into spring? So we have this wooden rod, as you can see. So we'll take this wooden rod and we turn or wound this wire around it. So when we turn the wire around the wooden rod, what will happen? When we remove this rod, this wire will act like a spring. So in your plan, you should include instruction for making a spring from the wire that is provided. So how we can convert the wire into a spring, if we want to convert the wire which is available to a spring. So the first thing, we'll take a wooden rod as they mentioned, and we will winding the wire around the rod. So it will turn to spring. So the first instruction, how we make a spring by the wire, by winding the wires around the wooden rod. So that's how we convert the wire into a spring. Then what you will measure, because whenever we are adding a load, how much extension or change in length it costs. So the thing which we will measure the original length, we will measure the load, the mass which is added, and we'll calculate the final length. So the quantities which we will measure for this experiment, we'll measure the added load or original length. Original length means the length of a wire of a spring without any load. We'll measure the added load, how much load is added. And the third thing which we will add is the final length. And we will, from this, we can calculate the extension. The final length minus original will give us what is the extension of the wire. The instruction to carry out the experiment. How we will do this experiment? So we will hang the wire, we will hang the spring. So we will, because we already convert the wire into a spring, so we will hang the spring, measure the original length without any load, and then we will add a load and we'll measure the final length. And we will repeat the experiment by changing by the load as well as by changing the type of a material from which the spring is made from. So the procedure for this experiment, we will hang the load or we will hang the spring first. We'll measure the length. We'll add load, measure the length again. calculate extension, and then we will repeat the experiment with other types of materials or other types of springs. Then the variable you will keep same to ensure a fair comparison. So if we want to compare, because we want to find how the type of a material can affect the extension. Like one spring is made up of, say, iron. One of the spring is made up of iron. Another spring example made up of aluminum. Another spring is made up of copper. So we want to identify how the type of a material can affect its extension. So what parameter we should keep constant or keep same for a fair comparison? That should be the original length, the starting length, because original length can affect the extension as well. The thickness, they all should have the same thickness. The mass used or the load used should be same. Like if for a spring one, for a spring which is made up of copper, if we are using say 10 gram mass, so spring 2 we should also use 10 grams. Spring for iron also 10 gram, for aluminum also 10 grams. So the load which we are using should also be same. Any precaution you should take or difficulty which might occur whenever we are doing the experiment in which we are measuring a length. So there is always a parallax error, or when you are measuring a length of a spring, because spring is continuously vibrating. So you should wait for some time before measuring the length, like wait for a spring to settle down or stop vibrating, then you will measure the length. Precaution taken or any difficulty which might occur. So the difficulty is measuring a length of vibrating spring. That is a difficulty, and how you can overcome that. So wait for spring to settle down or stop vibrating. Then how you will present your results. So how we can present our result? So we will present our result by either use the table you can draw, or you can also have a graph for force and extension. So you can plot a graph between force and extension and you can represent the result, or you can also draw a table with a column heading. So we will have a load. The first column will be the load. Then we will have extension of spring A, B, and C. So L is there. That is a load which is in Newton. Then extension for spring A normally in centimeter, for B and for like spring made up of iron, spring made up of copper, and spring made up of aluminum. So this was an experiment from Feb-March. Another experiment from summer 17 paper. A student is investigating whether the resistance of a wire depends on the material from which the wire is made. And the resistance can be calculated by a formula. Resistance is the ratio between voltage and current. The following apparatus is available for the student. An ammeter is there, a voltmeter, a micrometer, screw gauge to measure the thickness, and a power supply is there, variable resistor is there, switches are there, connecting lead, and a wire made up of different material. Plan an experiment to investigate whether the resistance of a wire depends on the material from which it is made. Draw a diagram of a circuit you will use to determine the resistance. So what we will do, like example, we will have a sample, a wire. To calculate the resistance, we need the voltage and we need the current. And to measure the voltage, we connect a voltmeter that is in parallel. And to measure the current, we'll connect an ammeter that is in series. But we normally want to repeat the experiment. So how we can repeat the experiment? So we can have a variable resistor here, which can change the voltage and current in the circuit. And there will be a switch as well. So this is a sample of a wire. There will be a volt. We'll read the voltage by using a voltmeter, and current by using an ammeter, and voltage divided by current will get the resistance. So this is a circuit. And when you draw this circuit, the total marks, the distribution, the mark distribution for a circuit, that 3 marks are there. 1 mark is for mentioning the correct symbol for power supply, ammeter, voltmeter. 1 mark is for the correct circuit diagram order. And 1 mark is for mentioning we'll measure the voltage and current to get the resistance. Then explain briefly how would you carry out investigation, including the measurement you take. So how we carry out the experiment? We'll connect voltmeter and ammeter. Then we will find the resistance by using a ratio between voltage and current. And whenever we are doing experiment, so we should repeat the experiment. Repeat experiment with different voltages and current. And because we want to find how the type of a material can affect the resistance, investigating whether resistance of wire depends on the material, then we will again repeat the experiment with a different type of wire. So this is how the procedure, how we carry out this experiment. State the key variable that you would control. We know the resistance. Resistance depends on the length. Resistance depends on the cross-sectional area, and resistance depends on the temperature as well. We are only investigating how the type of a material can affect the resistance. So rest all the other factors must be kept constant. So we should take equal length of all the wires, the length of the wires, the area of the cross section of the wire, and the temperature. These all factors must be constant. If these factors changes, the resistance of a wire will also change. Then draw a suitable table with a column heading, how you display your reading. So how we'll represent or display, we don't have to write anything, we just have to represent how we display our result. So we will have, because we are measuring a voltage, we are measuring a current, and we are calculating a resistance. So voltage and table, whenever you draw a table, must be with a column heading. So voltage is by voltmeter, and the unit is volts. Current is by ammeter, unit is amps, ampere. And the resistance you will calculate by using a ratio between voltage and current, and it will be ohm. You don't have to write any numbers here. You just have to draw a table to represent how you display your readings. The last October 17 paper, in which we have to plan an experiment. A student has the following apparatus. As you can see, this is a simple pendulum. Is there? Student is investigating whether a diameter of a pendulum bomb affects the time period. So, is there an effect of the is there an effect of a diameter on the time period of a pendulum? So, how you plan the investigation? You just follow the steps. A student has the following apparatus available: 1 centimeter polystyrene bobs are there, which is of a diameter 1, 2, 3, 4, 5, and 6. Then plan an experiment to investigate whether a diameter of a pendulum bomb affects the period of pendulum. List additional apparatus, because whenever you want to measure a time, what you need a stopwatch. Without a stopwatch, we cannot measure the time. And for a fair comparison, because we are finding whether a diameter, the size of a bob, can affect the time period. So for fair comparison, the length of the pendulum should be same. So how we can measure the length of the pendulum? For that purpose, we need a meter rule. So additional apparatus, what we need for this experiment, we need a stopwatch to measure the time, and we need a ruler or a meter rule to measure the length of the pendulum. Explain briefly how would you carry out the investigation. So for a time period, what we will do, first we'll mark the mean position, or mark the fiducial points, or we can say mark extreme and mean position. Release the pendulum from extreme position. Start the timer, the stopwatch, then record the time for like 10 oscillation or 20 vibrations. Then we'll find the time is equals to the time for 20 oscillation divided by number of oscillation. We'll get the time period. Then we will repeat the experiment with different size of box. Like we did the example for 1 centimeter, then we'll do for 2, 3, 4, and 5. So this is how we carry out this investigation. That's a plan. Next is state a key variable that we will control, because we are only investigating how the size of the pendulum, how the size of the bob can affect the time period or oscillation of a pendulum. So what other parameter must be kept constant? Amplitude, the distance from mean position to extreme position, that is the amplitude. The length of the pendulum should be same. And the material from which the pendulum, they already mentioned, that is same. So our number of oscillation which we are carrying out, that should also be same. Then draw table with a column heading to show so how we represent our result. So we'll have a diameter. Then we will have a time for 20 oscillation, and then we'll have a time period. Because diameter, we know we have 1, 2, 3, 4, and 5 centimeters. So diameter in centimeter. So we can write number here 1, 2, 3, 4, 5, because we know we have 5 different bobs are available. Then T is the time for 20 oscillation, and capital T is a time for 1 complete oscillation. Yes, for point 3, you can also mention the number of oscillation or number of vibration. That's also true. So this is a table. Then how would you use your result, reading to reach a conclusion? So to identify what is the relation between the two quantities, the best way is plotting a graph. So what we can do, we can plot a graph between the diameter on x-axis, y on x-axis, because independent variable should be on x-axis and dependent variable on y-axis. So diameter we are changing, diameter is in our hand, so that is independent. And time period on y-axis. We don't have to sketch this result. We just have to mention, we'll plot a graph for time period and diameter and check a relation between them. If it is a straight line passing through origin, it means they are directly proportional. If there is a curve, the graph is curved and the product is constant, it means they are inversely proportional. But again, you don't have to sketch any graph. You just have to mention that plot a graph between diameter and time period and check the graph for the relation between the two values, two quantities.